Thanks, Chris. It's great to be here, and I think this will be a great topic to hit on after our last group of speakers. I thought that panel was great. Looking at maybe more of the I/O, the hard logic downstream. What we're really going to be talking about is more of those day two operations, that mass orchestration of devices. So I really think as we look at this, as kind of as a number of the speakers said, look at it holistically. This is going to help tie it together from what does this look like when we have 100, 1,000 devices out deployed in the field. So I'll start sharing, but I'll give Carl some time here to introduce himself as well.
Thank you, Cole, and wholeheartedly agree with the previous panel. Exciting times indeed, with a background in more of an IT style, distributed orchestration and automation. The containerization of the assets from CODESYS is truly an interesting and very, very dynamic movement here. So I'm Carl Moberg. I'm the CTO of Avassa. Towards the second half of this presentation, I will talk about what we've built here, but I will say up ahead is that distributed management and orchestration and day two operations of containerization is my topic for the day. So very, very happy and excited to be here. With that, Cole, why don't you introduce yourself?
Yep, thanks. So my name is Cole Wangsness. I'm a solution architect here at OnLogic, so primarily focused on how partners can work with our hardware. Being CODESYS being one of our partners, as well as Avassa, I thought it was a really great opportunity to tie these technologies together. So I'm going to give a little bit of a primer for Carl's deep dive here. And then provide a little bit of information on logic, but let's start by just setting the stage here. I think a lot of people in the audience here are probably familiar with OnLogic, but just in case you're not, we're a manufacturer here based in the US of industrial PCs. So this is everything from small form factor gateways that are great as a CODESYS softPLC, both industrial, really made for more of a manufacturing environment, rugged systems that are made to be deployed out in the field and subject to very wide temperature ranges, power inputs, shock vibration, panel PCs, which are great for HMI and visualization, as well as edge servers, which gets more into the AI workload segment. Really our customers with y'all are the exact same. Really, it's those industrial focused applications where we work best. So I thought it'd be helpful, kind of from my perspective, being a little bit of a different contributor in this segment, to really talk about the landscape that I've seen. Years ago, I would say that like edge landscape was changing. I will say now it has changed, right? This concept of connected edge assets, while not everybody's adopted it, companies want to act on data. They want to digitize plants. They want to interconnect, as a number of speakers mentioned, SCADA, DCS, MES systems together. There are, challenges to these brownfield deployments that we need to overcome. And there's some uniqueness site to site, right? What's deployed out there? I've been to facilities where they've had 8 different brands of PLCs that have deployed over the years. So having something that can bring those assets together is really a great thing. And one thing that I really liked that was mentioned previously was, it can be painful to lift and shift the complete architecture over time, or all at once. The gradual approach to say, I'm going to move to soft PLCs, and then I'm going to look at what my other systems look like so that I can say, this might not be a single vendor setup day one, but I can move towards a streamlined architecture long term. With that, IT and OT convergence, you've probably heard it 1,000 times at this point. The idea of scalable, workable tools in OT, similar to how IT has a DevOps pipeline, from what I see, are increasingly being asked to work hand in hand. And obviously the elephant in the room, AI. at the edge has been a major talking point for years. I think obviously there's been some acceleration over the last, but I always like to think we've kind of been ahead of it, from the transition with vision systems from really rules-based to a lot of ML, as well as, many companies taking their historian and looking at, how can I look at predictive maintenance on tags? We've kind of been at the forefront of that. But there are definitely some continued challenges, especially apparent now, right? Cost and ROI is increasingly becoming an issue where we're being asked to do less with, we're being asked to do more with much less. Decision makers want to see that quick return on investment, and reducing cost is being prioritized. And I think, as some of the speakers mentioned, right, the lowering the hardware cost can be one way to do that. There's definitely a skills gap towards whether, the legacy systems, there is that ticking clock of, will we have the people in place to maintain them, 10, 15 years from now, or even less? And, there's definitely also a focus on security. I mean, I also work specifically with our oil and gas segment. Colonial Pipeline is still something that's talked about, I think, on a regular basis. Thankfully, it's been 2 years since the last time a plant manager's asked me, about master passwords and label printing out that on an HMI. So I do see some progress there, but there's still a ways to go. And really why I say this is that, there's never been a better time to start playing with soft PLCs. And the architecture with Virtual Control SL that CODESYS has put together gives us a lot of interesting opportunities. So I'm not going to do a deep dive into that just yet, but just talking about some of the potential, right? We can standardize on the hardware. When you look at us as a hardware vendor, any x86, most ARM platforms, we can look at using with IP-based field bus protocols to get a lot of functionality out of devices, make it so that a device can be replaced easily. The improved manageability, right? So CODESYS has a number of tools for deployment, but I'm really going to let Carl talk about this in a moment here, right? That standardized framework, being able to have and I love during the panel, creating packages based on the IO devices, creating it so that it can be agnostic to the device. And so it makes it easier to deploy and easier to scale quickly. That really makes it interesting to us as a hardware vendor. And then from there, failover capabilities, the co-location of workloads. I'm going to hit on that in a little more depth. But there's really some interesting things we can do here, where we can take an architecture and flex it to what a customer or, you may need as an end user. So, from an HMI and an IoT use case, stuff like when we put CODESYS in a container, allowing us to run other services right there on the device. If we have a virtual control instance, running runtime, we can have an edge security agent, monitoring network traffic, looking at packets, preventing DDoS attacks. We can have MQTT brokerage services, whatever connections you need to make, right? Going back to that idea of connecting to maybe other line of business apps, in a cloud environment or, a SCADA system, we can make those interconnects directly in the box. And through, the flexibility that CODESYS brings, we can use any number of those field bus protocols. On the HMI side, go ahead, Carl.
Just a really brief question, because this really triggered something here. If you look on the left side here, are there any particularities around security with co-hosting that you guys have been challenged on, or in your observation or your experience that has come up? Because I can see some pretty valuable assets running side by side here. Any thoughts around that? Yeah,
so I think today I'd categorize it in two ways. One, I would say direct attacks on infrastructure, as certainly more in the preventative sense. So, right, looking at preventing DDoS attacks, rerouting traffic, if there are those instances. But another one that's increasingly come up is this, as NIST published a standard roughly 3 or 4 weeks ago, is this post-quantum encryption piece to it, meaning that data is being stolen now, valuable data and logs, everything can be stolen now, decrypted later, which presents a challenge for the future, both from, criminal actors as well as foreign governments. Right, a lot of the controls we're talking about can be, more in the utility space, can be on critical infrastructure. So looking at how we secure that can be critical. We've got partnerships with both, and, I'm happy to talk through that if anyone sends me an email. But that's definitely something we want to be looking at and continue to improve, as well as, to what you're going to talk a little bit about, the fundamental security we build into our architecture.
Thank you. Got it.
Oh, that was a great question. Thank you, Carl. Looking at the HMI side, right now in this use case, I've said, let's make it all one vendor. As we know, it can't always be possible. So if we want to deploy whether it's, web or target Visu, or whether it's, a, MES or a SCADA visualization session, we can make those interconnects. And then further, using the gateway service, we can interconnect devices out in the field that we may want to be running the runtime on. It just gives us a lot of possibilities, especially for these, IIoT type use cases. Now, before I hand it over to Carl, one of the things that really interests me specifically, and I've put a rack mount server on this slide for illustrative purposes only. This really, most of the time in my mind is the more like a Core I small form factor device, and more so on the node level redundancy, not necessarily the replication on the host, but making redundancy across devices so that if we are, let's say, centralizing a number of streams through an Ethernet switch to a semi-centralized device or in a hub and spoke architecture, we can have the CODESYS runtime be redundant across the nodes. And then if we do have those legacy servers and historians, then those can be placed on those devices as well as replicated generally. So this architecture, the ability to easily deploy packages via containers, gives us a lot of that flexibility to really architect things in a number of different ways based on the customer's requirements. Probably something you're thinking of right now, right, is this idea of how are we going to orchestrate the device scales? And this is something that really hits well on a container-based architecture, and where Avassa's offering is really keyed in to make things great for a customer. So I'm going to turn it over to Carl and let him talk a little bit about Avassa's offering.
Thank you so much, Cole. And I'm going to ask you to advance the slides for me now and then. So I'll start in here. So as a company, we have been on the market doing container management for distributed environments for a couple of years now. And I'll get to the kind of details about what a system like ours look like and some of the observations that we're making that I think can be highly applicable to what's going on here with the virtualization and containerization of the softPLC and the edge assets from CODESYS. But I also have a very strong observation and experience to say that as much as people tend to say that they know what containers are, some of them or a lot of my audiences have then kind of told me that they don't really. So I'm going to spend a couple of minutes trying to illustrate what containers are and kind of some of the benefits to them. So just in general, at a surface level, and I think maybe most of you guys know this, when people say a container, what they usually mean is a standardized unit of software that packages up both the code or the compiled manifests of code and all its dependencies in a well-known file format. And if you actually open up a container image, you will actually see that it's literally a tar file. So anybody who's been doing open systems like POSIX-based systems or Linux systems for some time will understand that it's an ancient way of just packaging up files. There's a couple of complicated things going on inside of the tar file, but at the heart of it, it's just a way of tarring up files. The really cool thing about that is that the architecture of containers is such that it's supposed to contain enough surrounding libraries, for example, so that it doesn't have to rely on external libraries or external things to be present on your Linux operating system. So you can reliably start and stop an application without going into what our Windows brethren call DLL hell or library hell, so that it's provably, hopefully, something you can start and stop on any container kind of runtime. So of course the name comes from containers that can be, loaded onto and offloaded from any standard, container format ship. So if you go to the next slide, Cole. So as I mentioned, a container image is just an archive file. Now, if you ask a container runtime, and the two common ones or most common ones these days are Docker and Podman. If you ask a container runtime to instantiate or run an image for you, it will know how to unpack the archive file. It will know how to lay out the contents of that. It will know how to prepare the Linux kernel to run the files inside of that image file. And the result, if it's successful, is a running instance of that container. So a container image fed to a container runtime like Podman and Docker usually results in at least one running container. So just to get that terminology in there. And I mentioned Docker and Podman. Most people say, when I talk to them, maybe they even say Docker containers. But a lot of things have shifted since the company now known as Docker kind of put containers into the mainstream. First of all, it's interesting from my vantage point that Docker is now more focusing on the developer environment rather than the runtime. So as a company, we see kind of a strong uptake around about Podman, which has its roots with Red Hat, still open source, but it's a kind of a Red Hat contraption. So particularly for these kinds of industrial environments, I at least personally expect more Podman than Docker based container runtimes over time, and maybe there are future implementations that will be dominant or more popular, but right now those are the kind of the two players that we have here. And of course, you usually run more than one container on your container runtime. This is kind of the advent of microservices, is when you put together a number of containers running on the same host and interacting with each other in a known fashion. But just to give you the basics here. So if we go to the next slide, Cole. Here's my take. There's so much more to this than just a container, image file format, and the fact that there are competing container runtimes, and the fact that you can run containers. For us as a company, it's really, really important that there's an industry-wide standard. And I'm using the word standard. I feel in this context, I should use the word standard in a careful fashion. I would say more that it's an opportunistic, collaborative, kind of loosely described thing. So none of the traditional standards bodies are actually involved. But interestingly enough, it seems to be stable enough that there are multiple implementations again for tooling. So if you have what's called an OCI compliant container, there's, in my mind, almost no chance that it won't work on any of the tools that you have. So as long as people stick to OCI compliant containers, like our friends at CODESYS, you are very likely to be able to run that on whatever set of tooling that you use. And it's not just the starting and stopping of the containers. It's also a whole slew of other things. Notably, and important for us, is how to publish, for example, a container image. How do you make a container image available? And how can you allow your tooling to fetch container images in a secure and a kind of well understood way is a huge benefit for the types of users where we have for example, the responsibility of publishing newly built containers and then putting them into production is maybe two different teams and two different tool chains. This becomes a very, very valuable thing. And people have always or usually come across things like public registries and repositories like Docker Hub and others, which again are very clever ways for people to publish their freely available, or at least their openly available containers. And another aspect that I think is going to be hugely important for this industry is the fact that there is a growing set of ecosystem of tooling to monitor, observe, and update the applications. There are kind of well understood means of how do you start an application, but then how do you actually update the version of that application, or how do you update constituent parts of that application? And how do you actually provide some at least basic means of monitoring, meaning is the application alive? Is it actually responsive? And actually, you can also define in fairly well understood ways application-specific probes to make sure that not only is the application up, it's behaving according to expectations. It's also pulled with it observability tools like how do you actually structure the fetching of logs and other, kind of traces of activities. So again, a really cool thing here is that there's such wide reuse of these kinds of ecosystem tools, not just to package and stop and start, but also fetch and publish, monitor and observe, and kind of life cycle things. And of course, maybe I'm repeating myself a little bit here, but that whole set of behavioral definitions around the fact that it's containers drove the whole idea of microservices that Cole almost touched on with his terms in kind of co-locating applications or application components that interact with each other in kind of known ways. So if you go to the next slide. So here's what we do. Here's kind of the kind of challenge that I'm taking on here at Avassa, is that we've found that when it comes to actually managing containerized applications, most of the industry is actually pretty well versed in doing that in the cloud. So most of the cloud giants have very good tooling for managing containerized applications in a centralized fashion. What we have found, and kind of the background of Avassa as a company, is that as soon as some of these enterprises were tasked with managing what they wanted to be containerized applications in the distributed domain, they found lack of tooling. And what they usually do intuitively is try to reuse the tools that they have for the cloud, and try to apply that to the distributed domain. And I'm sure most of you guys probably can describe better than I can that it's not a really good fit, because the distributed domain, the edge, if you like, is a pretty vastly different thing. The amount of locations, for example, drives a new, the need for a new way of thinking of deployments, for example. Monitoring and observing applications, if it's in the hundreds or even thousands of locations, is vastly different than doing it in a centralized fashion. So what we are going after here is helping people that need to run containerized applications in a multitude of locations, and where each location usually has a very resource constrained amount of compute. And you can see where this is going. Of course, this is kind of the entry point to where we come across users that are looking to deploy containerized versions of softPLCs, of course, from CODESYS, and this pattern becomes a really interesting one for us. If you go to the next slide. So what we have is something we briefly call an application management and operations platform for the on-site edge. And the good thing, of course, with this context is that what you guys think of as, of course, the environments where PLCs run, that's actually what we call the on-site edge. And this is just in contrast with maybe people thinking about your phone or maybe an Amazon data center as some sort of an edge. The on-site edge is exactly the kind of locations that run softPLCs. So if we go to the next slide. There's a couple of components to a solution like this, right? There's a need for a centralized means of managing your containerized applications, actually independent of whether it's containers containing softPLCs or if it's containers doing more general or generic IT tasks like a database or security agents or MQTT brokers. And usually there's a need for a web UI for people with that kind of ClickOps experience, but predominantly and over time, I think we'll see a lot of integration with mainstream automation tools through REST APIs and maybe command line interface. If you go to the next slide, Cole. The next thing, and this is where it comes, maybe relevant to the context also together with OnLogic here. The way this usually works for our customers is that they pick hardware, of course, from a competent vendor like our friends over at OnLogic. There's usually a little debate about Linux. That's still a hotly debated kind of topic. They either go for a commercial distribution, like from our friends at Red Hat, or put together something on their own, like a Yocto. They pick a Docker or Podman. Usually, again, we see more and more Podman here. And in this case, of course, they will use an agent from us called the Edge Enforcer. So they install an Edge Enforcer on top of Podman that calls home to the control tower. And if you go to the next slide, Cole. They build out their environment like this. So they add hosts with our agent running on them. And when they have enough of those, they realize that there's a couple of things that are important here. First of all, kind of going back to what Cole said, thinking about some sort of failover mode, looking at the application, its behavior, and setting up clustering so that it supports whatever nonstop action or nonstop capabilities is required. And the second thing, which is kind of a finer point here, and is an interesting one in the container world, is to make sure that there's enough features or enough services at the edge to allow an application like a softPLC to actually survive upstream outages. And that can be a pretty interesting topic, because applications like that assume things like the ability to send logs somewhere, to resolve DNS names and others. You want to make sure that that is available actually in the site for an application like that to stand a chance of survival. If you go to the next slide. So what it actually looks like, I'm going to try and kind of map this into the patterns that we see here. If you look at the left side, we kind of tease apart the responsibilities in many occasions, not in all, but in many occasions, between who's in charge of the infrastructure and who's in charge of the actual application. And in this case, my example is, of course, the CODESYS edge gateway and the virtual control, and its associated configuration. And for their benefit or for their purposes, what we provide here is a means of either integrating with their existing CI/CD pipeline. If they have that, it's early days still, so most of them actually do this manually, but they need a way to package up those assets, like usually a combination of the edge gateway and the virtual control together with their specific configuration. And they want to be able to deploy that with some targeting. And what we mean by targeting is to say that it's only meaningful to run these kinds of applications if the hardware that it's running on actually supports the use case. For example, has the right drivers or has the right Ethernet interfaces to actually do what it needs to do. So what we mean by targeted deployments here is a whole interesting topic on its own, but it's the ability to say to the control tower, in this case, our scheduler, please only deploy this kind of asset or this kind of application to the hardware that actually supports the use case. And also make sure to associate the right configuration in the locations where it's running. The really cool thing with this, of course, is that it really gives our users the ability to leverage on the investments they've already made in terms of IT operations tooling. Just by packaging this in a container format, many of the things that they've spent a long time on perfecting can now be fully reused for the edge use case, all the way from signed bill of materials to monitoring to observability tools to drill into behavior that's out of order without actually reinventing the wheel, which also opens up a pretty interesting amount of new ways of leveraging also the talents that they have in their teams. That doesn't have to be, at least not with the numbers, experts in the exact nature of the softPLC itself, but they can do a lot of good in the actual just deployment and lifecycle management and the monitoring and observability of it. So we are super excited, of course, about this kind of direction that CODESYS is taking. We've seen a couple of users that are now really diving headfirst into taking on the packaging of the edge gateway and the virtual control and reusing the IT operations that they already have in place, including day two features, fully also for this environment here. If you go to the next slide, Cole. Because of course, at the end, what we think is really exciting here is the ability to help teams like that to extend their capabilities to the edge and also cover critical features and critical applications like the softPLCs here, and really reap the benefits, of course, of just the general value proposition of edge, be able to work in an offline capability, have frequent deployments or configuration changes, to be compliant with the security postures for the edge, and then have a deep and broad ability for day two operations, including monitoring and observability. I know we're coming up against the half hour here, so I think I'll wrap up by saying thank you for allowing me to present this, and thank you, Cole, for the introduction and the setup here. Any final notes from you, Cole?
No, I think that was great. The one thing I'd have that maybe some users are thinking about here is, I think one of the great things about Avassa's platform is that, you can, we're talking about managing directly at the edge, right? I think from this architecture, people may be thinking, does this all have to be centralized? And the answer is, while we're creating a central registry, not necessarily everything has to be centrally managed, right? We have that interdiction. If you're looking at this from a plant manager perspective and saying, okay, well, I want to have a central repro of resources available, but I really need to manage locally, that's totally possible.
Of course, and absolutely. Yeah. That is, yes, for sure.